Assalamu alaikum warahmatullah. I'm already back. This is the second part of our today's class, inshallah. We have already started the the normalization phases. So I already explained to you what kind of phases that we have. Last thing I stopped on is that this status, so our design could be in any one of these status, but these status are cumulative. So each lower status is based on the above status. So we cannot be in the third normal form while we still have, for example, multi-valued attributes. So if let's say we don't have transitive dependencies, and we don't have any partial dependencies, but we still have multi-valued attributes, in this case, our design is not yet in the first normalization form, still not in the normalization form, the first normalization form. And also, it's not in the second, it is not in the third, it's not in the fourth, and so on. So, in other words, if our system in the second normalization form, it must be in the first normalization form first. Okay, we have to guarantee that our system in the first normalization form first, then after that, it could be in the second normalization form. Is that clear, guys? No answer. Clear or not? Is there anybody with me? I think all of you are here. Yeah. Okay. So I consider it's clear because nobody has answered. Okay. How our design could be in the first normalization form? I don't know what's happening with the record. Okay. Okay. Now, how we could ensure that our system in the first normalization form, we have to ensure these three things. The first thing is our design has no multi-valued attributes. I already explained this before, and you know how to make it. So if let's say our design has, for example, student, and this student has name like this, then the name has first name and last name, right? So in this case, when we create our table, we shouldn't create this. We should create only this and this, the first and last name. Okay? We shouldn't have multi-value. Also, if let's say we have skills like this, we make sure that these skills are converted into other table with a relation to the student. Okay? As I explained before, it's all about avoiding multi-valued attributes. Okay? So here we ensure that every field has an atomic value. Every field should has an atomic value. Okay? We couldn't have any multi-valued attribute. And multi-valued attributes are, as I mentioned, that has two double line circle. That's considered multi-valued attribute. So if we go to previous slides, you can see some examples that has multi-values in one cell. Okay, so here this is the first thing. Avoid that there is no multi-valued attributes, which will confirm that every attribute value is an atomic. Okay, so all relations are in first normal form. If these two are guaranteed, then our design will be in the first normalization form. Okay, is that clear, guys, or not?
Clear.
Yeah. So what do we want to do is to ensure This two, just ensure these two things, which is actually a one thing that if we don't have multi-value, definitely every attribute is atomic. Okay, and vice versa. So ensure this two to get this. Okay, clear?
Yes, sir.
Yes. Okay. Then what is atomic value? Atomic value means in every cell there is only an atomic value. So this is a previous example that we have taken in one of our previous classes. So as you can see here in this field, we have multiple values. We have pencils, erasers, rulers, and also we have quantity for every item. So this field, this cell is not an atomic, right? So that means we still have multi-valued attributes. So is this table is now in the first normalization form? Is it in the first normalization form?
No.
No,
Oh no.
because we have this case. We have this case also has the quantity and name. This case has two items, quantity. Oh, oh, what is this? Very bad.
Aiman.
Aiman.
Playing games while during the class, right? Unfortunately, I'm very sad about it. Really. Ayman, do you play game during the class?
No, it's a video.
The video.
Oh.
So watching video during the class. Unfortunately, really, I'm very sad about this. I'm trying my best to let you understand, to make you, to deliver my experience to you, and also to let you be able to do something in the real market for your life. Please don't waste this opportunity, because this course is very, very practical. And to get very good job later after you graduate, you have to have this kind of skills. Otherwise, nobody is going to hire you. Okay, I'm not going to talk too much about it, but please don't do it again. It's up to you. By the end, it's up to you. Even if you don't like the course, if you don't want to attend it, it's up to you. I'm not enforcing anyone to take my course. Okay? Okay, so now here, this table actually is not in the first normalization form, because this table has this mistake, this wrong thing, wrong design. We cannot save multiple things in one cell, in one attribute. Like here we have names of multiple items and quantities for multiple items, and also here, here, and here. So all of this causes that our system is not being in the first normalization form. In order to move it to the first normalization form, we have to get rid of all of this. We change the design to make them to make everything looks atomic. Okay. Also, the other example is here. So if let's say we have in one field here, we have multiple IDs of multiple employers or employees, and also multiple names for multiple employees, then this table is not in the first normalization form. Okay. What we have to do is to change. And now, is this a relation? So you see this scenario is based on the previous scenario, right? So this example has been modified to become like this. Am I right? Yes. So this one, 1, 2, 3, 4, 5, manager number. This guy manages, is the boss of these 3 people, right? So as we can see here, this guy is the manager of the 3 people. Okay, every single cell is having only one atomic value, right? So this is our concern in this stage. For the first normalization form, the concern only is to make every cell atomic. Now, based on this table, everything is atomic. So is it in the first normalization form? Yes. Now it's in the normalization form. Okay? Now it's in the normalization, in the first normalization form. Okay, let me write something here. Good. Now it's in the first normalization form. Okay, is that clear, guys? Is there anything hard for this stage?
Can you please recap just a little bit about the atomization again?
Normalization.
No, the atomic, the atomic one.
The atomic is to avoid multi-valued attributes. It's only to avoid the multi-valued attributes. So like this cell is not atomic.
So what does atomic means? Atomic is what?
Atomic means every cell has only one value for single attribute.
Oh, okay.
Understand? Yeah, like now, every cell has only one value, right? One value. Every cell has only one value, right? Also here is 1%. Okay? So this means this one is the name for the same person. Is not 2 names, right? So it's single value, because here is the employee name. Okay? So this means every cell has only single value. That means every cell is atomic. Okay? So now our table is in the first normalization form. Okay? Is there any other question before I move to the second normalization form?
No.
It's actually a kind of repeating the same thing that we have learned before, right? We already learned how to transform from the entity relationship diagram to entities, right? To relations, right? When we move from the entity relationship diagram, we have to take care about the composite attributes. We have to take care about the multi-valued attributes and everything, right? So this is one of the things that we have learned before. But after you finish your design, you have to check. You have to go and check. Go through the normalization stages, stage by stage, to check, to confirm that everything is going correct. Okay? So the first thing that we have to check is to make sure that our tables, in every table, every cell is atomic. Every cell has only one value. This is the first thing to check. If every cell has only one value, that means our design is in the first normalization form. Then we need to check, is it in the second? Is it in the second normal form? We don't know. So let us check, what is the second normalization form? What they call it here, one normalization form is a thing that we have to ensure before we check the second normalization form. So in order to check our system or to make our system in the second normalization form, our system must be first in the first normalization form, right? So the first thing we have to ensure that the first normalization form is confirmed. Then after that we check the second. The second normalization form, they call it also first normalization form plus. Also, it can be you can find this name as well. Anyway, first normalization form plus if every non-key attribute is fully functionally dependent on the entire primary key. Okay, let us go to this slide. Based on this slide, which one is the primary key here? We don't know, right? We don't know which one is the primary key. We don't know. Okay, then let us take this example. Okay. Here in this slide, what do we have for the primary key? We have the employee ID and the course title, right? These two fields are used as a primary key. So these two fields actually are the part of the primary key, and every field other than them is considered non-key attribute. Okay, non-key attribute. Okay, non-key attribute. So the non-key attributes here is what? Which one is considered non-key attribute? Can you tell me?
Name, department name, salary, non-key.
Date completed, right? So name, department name, salary, date completed. All of these four, name, department name, salary, and date completed, are considered non-key because they are not part of the key, right? They are not part of the key. So these four are non-key, right? And these two are the key. Okay, is that hard? It's very simple, right? Okay, so the condition here, or the constraint here to make sure that every non-key attribute is fully dependent on the entire primary key. Okay, not dependent on a part of the primary key. Correct? So let us check. This one is a non-primary key or non-key attribute. This one depends on what? Is it depends on the course title or depends on the employee ID? The name.
Employee ID.
It depends on the employee ID, right? Also the salary.
Yes.
Depends on the employee ID. So here, this field name is not fully depend on the two fields of the primary key. So this is a wrong design. Okay? So in this case, our table is not in the second normalization form. Why? Why it's not in the second normalization form? Because here we have this field, and this field. These three fields are based on only the part of the primary key, which is the employee ID. Okay? Only this date completed is based on the course and the employee. Only this field. But these three are not fully dependent on the primary key. Is it clear?
Clear.
Yes.
Yeah. Anyone has a question? Okay. Now, based on this design, our system is in the first normalization form because every field has only one value, but it's not in the second normalization form because some fields here are not fully based on the entire primary key, which is called partial dependency. So this one is called partial dependency. So partial dependency is not required, is not needed, it's unpreferable. So we have to avoid the partial functional dependencies. Every field must be dependent on the full primary key. Okay, So to make this design in the second normalization form, we have to avoid the partial functional dependencies. So every non-key attribute must be defined by the entire key, not by only part of the key. So figure 2.23 is not in the second normalization form. See 2.25. Okay, this one is not in the second. So what we can do here, how we can solve this issue? Do you have any suggestion?
Create two separate relation.
You know why this problem happened? Because we have information of multiple entities in the same table. Multiple entities in the same table. From the beginning, we learned that every entity should be in separated table, right? So in this case, we mix multiple entities in the same table. That's why we got partial dependency. So the best thing to avoid this is to save every attribute in, every entity in different or in separate file. Okay, so let us move to the second slide. Okay, here. What we have to do is to keep the information of the employee in the table here of the employee. So the name is based on the ID. The department also is based on the ID. The salary is based on the ID. So everything is fully based on the primary key here. Okay, so this table now is in the second normalization form. But we still need to confirm the second table, right? Because the other part, the date completed, is based on other, is saved in other table, right? So here the other table has a relation between it and the employee table, because it has a foreign key here for the employee table, and also it has the course title or course name, then the date completed. Okay, now the primary key is a composite of employee ID and course title, which is fully, the date completed of the course is fully dependent on the course title and the employee ID, right? So it, for the same employee, the complete date of any course is depends on the course and the employee, right? So we could have multiple or different complete date for each course for the same employee, right? So it depends on the full composition of the primary key. So here in two cases, in two tables, we don't have any partial dependency. So our system now is what? Our system now is in the second normalization form. So create this, it's in the second normalization form. Okay. Any question? Normalization, guys, is something like a checklist. So we have to go and check for everything. Make sure that there is no multi-valued fields to be in the first normalization form. Make sure that there is no partial dependency to be in the second NF normalization form. Then after that, we go and check other things. So here for the third normalization form, we have our tables must be in the first normalization form first. Then after that, we must confirm the second normalization form. Then we can confirm the third normalization form. So the third normalization form, in the third normalization form, the system or the design should have no transitive dependencies. No transitive dependencies. So what is the transitive dependencies? When one of the attributes functionally determines a second attribute. So when one attribute determines another attribute, which functionally determines a third. Okay, so one determines another, then the other determines the third attribute. Okay, let us take this example. Okay, this example here, relation with transitive dependencies, sales relation with symbol data. Okay, we have here customer ID, we have name, we have salesperson, then we have region, right? Okay, the question here, where is the transitive dependency? Can you tell me where is the transitive dependency? Before this, is there any multi-valued attribute here? Is there any multi-valued attribute?
No, no,
No, right? So the system is in the first normalization form. Okay, what's about the second normalization form? Is there any partial dependency? Is there any partial dependency? The primary key is the customer ID here. So the name is based on the customer ID, the salesperson is based on the customer ID, the region also is based on the customer ID. But there is something called transitive dependency. This transitive dependency actually is that the region here is based on the salesperson, right? And the responsible salesperson or the salesperson in charge who will deal with this customer ID actually is based on the customer ID. So here, one attribute determines another attribute, which determines the third attribute. Okay, so what does it mean? Here, if let's say we have Smith, right? Okay, let us delete this. Here we have Smith, another Smith, the same Smith, right? But this Smith actually is responsible to deal with different customers, right? So here, the same person, salesperson, actually for the same region, right? So this region actually is defined by this. This region is determined by the salesperson, and the salesperson is determined by the customer ID. So this is what they call it transitive dependency. Okay? This thing actually is not good design. We have to avoid. Okay? Any question, guys? Before we move, we have to take an example here. Okay, the example here in this slide, the relation with transitive dependency, in this case, like that. As you can see here, there is no partial dependency. Name is depends on the customer ID. Salesperson also can be determined by the customer ID, and also the region could be determined by the customer ID as well. Okay, but here we have another scenario, that is the region could be determined by the salesperson, and the salesperson could be determined by the customer ID, which is considered a transitive relation. So the transitive relation is like this. Okay, this is what they call it, transitive relation. Okay, how we can solve this issue? How we can solve this issue? What we can do is to remove the region and the salesperson together in one table, and we keep the customer ID name and salesperson ID in other table. Okay, as you can see here, customer ID, name, salesperson. Then the salesperson is a foreign key that's taken from the other salesperson table. Okay, so here the salesperson is this name and the region is this name. So we avoid having unnecessary duplicated data. As you can see here, Smith South is repeated. So if let's say Smith is assigned to the west, for example, then we have to go here and modify. We have to go here and modify. So this is what they call it, anomaly. Okay, so we have to avoid. In order to get our design free of all anomalies, we have to avoid the partial dependency, and also we have to avoid the transitive dependency. So Avoiding partial dependency and transitive dependency will make our design free of anomaly. Okay, so here in this design we can see that Smith is only one time, region is only attached to every salesperson. So if let's say Smith is moved to the west, then we go here only and modify Smith. Okay, here, okay, let us check now. Is every table here in the first normalization form? Do we have any multi-valued attributes? Definitely no, right? So
No.
it's confirmed our system is in the first normalization form. Is it in the second? Is there any partial dependency here or here? Region is
No.
based on the salesperson, which is the primary key. Salesperson also is based on the customer ID, which is the primary key. Name is based on the full primary key. So there is no partial dependency. Also, this system is in the second normalization form now. Okay. What's about the transitive dependency? Is there any transitive here? No, right? Because we just now solved the transitive dependency by removing these two fields into different table. Okay, so now our system or our design is considered in the third normalization form. Okay, so here is the explanation. Now there are no transitive dependencies. Both relations are in the third normalization form. Okay, any questions so far, guys?
No, doctor.
Okay. Okay, now after the first, second, third normalization form, we will come here and see the other normal forms. So the fourth one actually is called Boy's Code. Boy's Code normalization form, or maybe 3.5 normalization form, which is at the middle between the third normalization form and the fourth normalization form. Okay, so to ensure that your system or your design is in the Boy's Code normalization form, you have to ensure that all determinants are candidate keys. All determinants are candidate keys. There is no determinant that is not a unique identifier. Okay, here you have to know which one, because if you go back here, we still don't mention which one is the primary key candidate, or we did not decide finally decide the primary key, right? So here in the Boy's Code normalization form, we have to find the candidate keys, and we have to make sure that every candidate key is a unique identifier. Then, in this case, our system will be in the 3.5 normalization form. For the fourth normalization form, we have to make sure that there is no multi-valued dependencies. Also, in the fifth, we have to make sure that no lossless joins. Okay, we are going to go through everything. Then the last one is the domain key normalization form, which is the ultimate normalization form, perfect elimination of all possible anomalies. Okay, this is all normalization forms that we could have. Okay, but normally in most designs, three normalization forms are enough. Three normalization forms are enough. Okay, to ensure that everything is smooth and no anomalies, no any problem. Okay, let us consider this example. Okay, guys, this in this example, actually, we are going to solve the issue of the first, what they call it, first normalization form. Okay, here. This is a department complaint. Department complaint. Okay, in this design, is there any multi-valued attributes?
Yes.
Yes, right? Because this here actually is the same field. This is the same field, the same field, the same field, and the same field, like this. Okay, that's why it's considered multi-valued. I would check, yeah, if this is a table, I'm going to join it. Merge this, merge also. This is to be merged. Okay, so now here we have, based on this design, we have multiple values for the same attribute, right? Like here, here, and here. The first thing, we have to avoid this from happening. So what to do? What to do now? We have to create records for every case, right? So it seems that we have to return back the things. By purpose I left it like this last time, but I just forgot now. So here we have to make sure that this is the case. Okay, so this is one record and this is another record. So for this case, now if we make it like that, is there any multi-valued attributes? Is there any multi-valued attribute? No, right?
Yes.
Yeah. Okay, what we should do now after this, so the system now is in the first normalization form. What we have to do now, we have to make sure that the system also in the second normalization form. Okay, to be in the second normalization form, what we have to avoid? What do we have to avoid?
Partial dependency.
Partial dependency. Okay, this is our design. I bring it here to the paint to easily draw. Okay, so here, is there a partial dependency? What's the primary key first? Primary key looks like this one and this one, right? Because they have the hash, right? Okay, suppose that this is the primary key. So here, the department name is based on this only, right? It's not based on the customer. Also, the location is based on the department number. The manager name is based on the department number. The manager ID is based on the department number. So this is, all of this are partially dependent on the primary, on a part of the primary key, right? While the customer name is dependent on this, the date of complaint is dependent on this, and nature of complaint is depends on customer also. So this is partial, right? Telephone extension, maybe it could be dependent on the department. So based on this, what we have to do is to divide or to remove this entity to one table and the other entity to another table, right? So in this case, what we will have? We will have multiple tables like this. Oh, sorry. So this is going to be one table and the other one is going to be another table. Okay, now is our system now in the second normalization form? Is it in the second normalization form? Yes, it looks like it's in the second normalization form. Okay. Is it in the third? Is it in the third normalization form? Can you check?
Yeah, no.
Not in the third normalization form. What's about the
I think
others?
no.
Yeah, it's not in the third normalization form. Okay, can you find where is the problems? Where is the transitive dependencies in the first part here? Is there any transitive here?
Date of complaint
Uh-huh. What happened?
depend transitive date of complaint and the nature depend on the nature of complaint depend on transitive to customer.
Yes, correct. So this one, this field is depends on this field, and this field is depends on the other one. So this one is called transitive dependency. Okay. Okay, so this is correct. uh, Correct doesn't mean that the design is correct. Correct, it has a transitive dependency. So what we have to do is to avoid this. We have to remove this. Okay. What's about the other table? What's about the other table?
Location and manager name.
Location and manager name. What happened to them?
Oh no. Transitive dependency.
Yeah, there is transitive dependency. Where is it?
Manager and department name.
So how?
Manager name is transitive to department name, I think.
No. Manager name
No, okay.
is based on the ID, right? Then the ID is based on the department. Manager name depends on the is based on the manager ID. Then the manager ID is dependent on the department ID. So for every department, we will have only manager ID, right? One manager ID. We cannot have two managers for the same department. Right or not? Is it right or not, guys?
Right.
Yeah. So here, the manager name is dependent on the manager ID, and the manager ID is dependent on the department. So what we have to do here is to remove these two fields, and we shift them to another table. We shift them to another table. How we can make this? I'm going to copy this here to other table like this, and this one is going to be attached to this here, because every department has a telephone, has a location, has a department name. So now everything here is fully dependent on the primary key. Every field here is dependent on the primary key. This one is fully dependent, fully dependent, fully dependent. And this one is fully dependent on the primary key. This one is the primary here. And this one is also fully dependent, fully dependent. Oh, this one is not. Okay. What we have to do here for this table, let us take it one by one. So we take this one here. This one also need to be repeated. Control C, B, oops. see. So here, this one have to be used here. So this is going to be a foreign key. This one is going to be a foreign key from here. Okay, so this one is one side and this one is the many side, right? What's about the other side here of this? In this case here, what do we have to do is, I'm going to print screen and copy this if it could be copied. Yes, because we need a lot of okay, I want to make it clean for you guys. Okay, so here what do we have to do? Manager ID and manager name supposed to be moved out in one table. Then this one is supposed to be covered here. Okay, this is going to be shifted from here to here. Okay, and this one actually is going to be removed also in other table here, while this one like that is going to be covering this. Okay, so in this case here, in this case, the primary key could be this. This is the primary key. So this date, this nature of complaint is fully dependent on 2, right? On the full primary key. Because maybe in the same date we have 2 complaints, but every complaint is for different customer, as you can see here. So we can see that every complaint has different nature, right? Why? Because it depends on the date and the customer. Okay, also here, this one is fully dependent on the customer ID. This one is fully dependent on the manager ID. This one is fully dependent on the department ID, and the primary name, primary key is here. Okay. What do we have other than this? We have a relation between this and this. So this one is 1, this one is many. Also, we have customer, but this customer actually is supposed to be attached to another department, right? So every customer is supposed to be attached to a department. So I have to remove this first. I have to take this, Ctrl CV. So this one's supposed to be also here. Okay. So primary key here is for this field, for this table is the department. So the department actually is a foreign key here. Okay, so this one's supposed to be foreign key like that. Okay, this one is a primary key. Also, this one is a foreign key, which is connected to here. So this one is the multi-sign. Okay, and this one actually is coming from here. This one is the multi-site. So every customer could have multi-complaints, right? So this one is a primary key and foreign key part at the same time. Okay? Are you with me, guys?
Yes.
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 Yes, Doctor.
Okay. Okay, good. So based on what I have done now, is there any multi-valued attribute? Because now the design changed. So after we change the structure of the table, we still have to check the multi-valued. We have to make sure that we don't have any multi-valued attribute. We have to make sure that there is no partial dependency. So partial dependency is not available. We already guaranteed that. Is there any transitive dependency here? Is there any transitive dependency? Also, this department is fully based on the primary key. Can you check any, can you find any transitive dependency? No, right?
No.
So the system in the third normalization form. Okay? Okay, guys? Is that clear? Abdul Aziz, what happened? Why you say no? It's clear. Okay. Okay, so so far, is there any question? Is there anything not clear? One more thing I have to correct here, because when we do normalization, we have also to correct the data at the same time. So this part is supposed to be removed. This part is also
Doctor, there is a question at the chat.
There is a question at the chat.
Doctor?
Okay.
Yes.
What is the question? Doctor, this means that this example has 4 entities, right? Yes. Yes, this example has 4 entities. And why we had a lot of wrong design? Because here in the initial design, we combine 4 things, 4 entities in the same table. That's why from the beginning, to make your life easy, to make your also team manager or maybe your senior life easy, from the beginning, never combine multiple entities in the same table. Never. Okay? Deal, guys? Yeah. Okay. So here, there are 2 approaches. I don't know what's in the slides, really. But let us go through and see if we did well or not. So there are two approaches to remove repeating groups from unnormalized tables. Remove the repeating groups by entering appropriate data in the empty columns of rows containing the repeating data. Remove the repeating group by placing the repeating data along with a copy of the original key attribute. In a separate relation, a primary key is identified for the new relation. Oh my God, it's going to confuse you guys. Okay, anyway. So at the beginning, we have to copy the data and we put it here in the second row to avoid the multi-valued attributes. And we have done that. But after that, we realized that there is partial dependency, right? There's because these fields are based on the department. That's why we moved them in different table. Then after that, we realized that these things are depends on the customer. That's why we removed them into another table. Okay, and we take the primary key from here. We put it here. Also to make sure that the customer is always linked to the department. Okay. Then after that, we found that this partial dependency in the complaint, so we decided to remove this part into a separated file called customer. So here, every non-primary key is fully dependent on the primary key, and also here, everything is dependent on the primary key. Also the same thing here. Okay, let us so now we remove the partial dependency, right? Because this one is partial dependency. We remove it, everything is fixed. So in the third slide here, we have to remove the transitive dependency, which is the manager name and the manager ID. So the manager is supposed to be in different table. So this is here is the final design. Okay, this is the final design. Okay, so bring send to back. Okay, this is the final design. Shape fill like this. Okay, is it similar to our design or not? Department, department name, location, manager ID. This one is exactly as our design. Then we have manager table, manager ID, manager name, customer, customer number and customer name. Then we have here department, customer. Okay, now their design is not correct. Okay, this design is not correct. Why this design is not correct? Because here this department is supposed to be here. Supposed to be here because every customer is belongs to a department, right? Here they combine the complaint together with the department. Do you understand this?
I understand.
Yeah.
Yes,
So here, if we delete every record here in this table, what we will have? We will have a deletion anomaly. If we make this table empty, then we will lose the relation between our customer and their departments, right? Right or not, guys?
Right, right.
Yeah. If this is happen, then our design is not correct. So what we have to do, we have to remove this department ID from here, and we attach it to the customer ID, to the customer table. Okay. So if in that case, if we delete all complaints, our customers are still attached to their department. Okay.
Okay, that's it.
Yeah. For this mistakes in the slides actually is not my fault, because these slides are given from other department, and that's why we have to follow. Anyway, I'm going to delete this. I'm going to
the one thing.
close it. Yes.
Uh, if we create many tables, won't it take many data?
Sorry.
If we create many tables, won't it take many data?
I couldn't understand. What do you mean? Really, I cannot hear you very well. Hello.
I write the question on this chat.
Okay. Write it better. Anyway, I'm going to fix it better. Okay. Yeah. Okay. The question is, if we create many tables, will not take many data? What do you mean? Take a lot of space? No, no. Because if we create many tables, but only one table for every entity, for each entity is only one table, then it's going to be the minimum consumption of data. If you mix the things together in one table, it's going to consume more space from your table, from your hard disk. Okay, is that clear? Because if we keep the things in the same table, then the data is going to be repeated, right? As you can see here, the same record here is completely repeated, right? But here, after we improve the things, then this is not going to be not going to be repeated. As you can see here in my diagram here, I already deleted these two parts, right? So this part is already minimized, and that part is already minimized. Correct or not? Is it correct or not? Is it clear?
Yeah, doctor.
Yeah, okay. Let us count it. How many fields saved in our database now based on the new design? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, 19 fields. Okay, 19 fields. Okay, let us consider this. Here, in this table, how many fields? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2 means 20, right? 20 fields here. Am I right? So this is a very big issue for the, what they call it, for the data duplication. And the number is only, in our design is only 19, right? The difference is only one field. It looks very, very simple, right? But because this one is a very simple scenario, if we take a very big scenario, then the difference will be a very big. Okay. Also, the duplication is not the only issue. The other issue is the anomalies, the insertion anomaly, deletion anomaly, modification anomaly that makes your life miserable and also makes the system in inconsistency mode, inconsistency situation, which is not going to allow your system to become an accurate system. So the accuracy will be lost. Okay, do you understand what I just explained?
Yeah.
Okay.
Yeah.
Okay, let us finish because we almost finished. In a nutshell means to summarize. So a table is in first normal form if there are no repeating groups. All the key attributes are defined. All attributes are dependent on the primary key. Okay. A table is in the second normal form if it's already confirmed in the first normal form, because this one is cumulative as I mentioned. So it cannot be in the second while it's not in the first. Okay. So we have to ensure that the first normalization form is confirmed. Then it includes no partial dependencies. Okay. Table to be in the third normalization form, it has to be in the first normal form, first and second normal form. Okay, is that clear? Then after that, it contains no transitive dependency. So the most important thing is to avoid this transitive dependency, is to avoid the partial dependency, and also to avoid multi-valued attributes. I don't know why they changed this here. They confuse us. Every semester they modify and they confuse. Okay, I will add something else here to make sure that this slide is in line with the previous slide. No multi-value attributes. Okay, so this one is also need to be avoided. That's all, guys. This is all this is all about our class today. Okay. Now here we have an exercise. Exercise 1, exercise 2, exercise 3. For exercise 3, I'm not going to consider because it's still too hard for you to understand. Here, exercise 2 and exercise 1. So for exercise 1, I'm going to explain to you here. Exercise 2 is an assignment. Okay, assignment must be submitted before next Monday. Okay. Here, this design, I'm going to copy this and put it in the I'll take a look here, the paint. Okay. Here, is this design in the first normalization form? Is it in the first normalization form? Quickly, guys, we don't have enough time.
No.
It's not in the first normalization form. Why? Because it has multi-valued attributes, right? All of them are multi-valued attributes. Okay, so what to do here? What to do here is to avoid this multi-valued, right? How to avoid this multi-valued? As they explained in the slide. So what do we have to do is to make sure that this one, this field, the repeated groups is like this. I'm going to take this here. So instead of this John key, we have to move this here and copy this, Control C and V. Then we bring it here. Then we copy this again. We shift it here. We copy this and it doesn't want to move. Okay. Like this. Then we draw a line here. So in this case, do we still have multi-valued attributes? Do we still have multi-valued attributes?
Yeah.
Yes. Which one? This one, right? This one and this one. So also this one need to be taken into other field. So what we have to do here, we have to draw another column and we call it quantity. So we bring the 6 here and the 5 here. Okay, then we keep the line here. We also need to remove this 6. We need 5 and this 6. We remove them. Okay, so in this case, do we still have any multi-valued attributes? Oh, sorry. This one is an address. This one is an address. It's not a multi-valued attribute. Okay, here, is there any multi-valued attribute now based on this? I'm not talking about this part. This part is also the same thing. We have to copy this and we make 3 copies here like that. Then we divide like this also the same way. Okay? If we do this, is our system in the first normalization form? First normalization form or not?
Yes.
Yes, it's in the first normalization form. Why? Because we don't have any multi-valued attribute. But before this, it's not yet confirmed. Why? Because Before this, we have also to mention which one is the primary key. Because if you see here, they missed to talk about it at the beginning, but later here they talk about it. There are no repeating groups. All the key attributes are defined. So we have to define the primary key. We have to define the primary key. Okay, where is the primary key now? We have to choose. Which one is the primary key? Is it client number?
Client number.
Okay, what's about the rent and the owner name, and this, all of this? Should we consider the property number as well or not? Because this one is all about the rent, right? So it's supposed to be the property name number and the client name number, right? Because the property number belongs to an owner, and the property number is rented to a client. Okay, so if we do this, then the system is confirmed in the first normalization form. And now if we want to check the second, is there any partial dependency? Yes, because the client name is based only on the client number, and the property address is based on only on the partially on the property number. And also here, this one owner name is based on the property number. This one is based on the property number. Rent to finish and rent to start depends on both. Okay, so here we have, this one is partial dependency, this one is partial dependency, partial dependency, partial dependency. We have 4 cases of partial dependency. What we have to do here is to remove this partial dependency. Okay, to remove this, we have to fragment our design or our table into, I'm going to delete this because data is not our business for now. So we have to remove the client here to another separated table. Okay, Ctrl C and V. Then after that we bring this here, client number. The primary key is here. Then what do we have to do is to remove this from here, or maybe we copy this that way. Okay. Oh, not yet. Okay, we need what we need to do is to remove this property number and property address. We have to remove it in different table, and also we have to keep track with the owner for the property, right? So this tables or these fields have to be together. Okay. What's about the rent? This one is not needed anymore. Rent to finish, rent to start. Also this one is not needed, like this. And this one is also not needed. Okay, so the primary key here is the client number and the property number. Okay, what's about this now? For the client table, is there any partial dependency? No partial dependency, because this one is fully dependent on the primary key, the name. No transitive, because this one has only one non key field. So there is no partial dependency. Partial dependency, no. Transitive dependency, also no, for this table. Okay, so this table is in the third normalization form. Okay, what's about the table of the property? The table of the property, this address is based on the property number, owner is based on the property number also. So there is no partial dependency. Actually, partial dependency cannot happen when we have only one field for the primary key, because this table has only one field for the primary key. Easily you can say immediately, if the primary key is only containing one field, so that means there is no partial dependency. Don't think about it. When the partial dependency could happen, when the primary key has more than one field. Okay, so in that case it could happen. So what we have to do is to check this table. So the rent start based on property and client, right? So it's fully dependent on the full primary key, and also the rent will finish based on the full primary key. The rent actually itself is based on the full primary key, right? So here also there is no transitive, no partial dependency. Okay, is there any transitive dependency here? Is there a transitive dependency? Answer please. Is there a transitive dependency?
No.
Are you sure?
There is a transitive dependency on the client table.
In the client table. Oh, in the wrong place. Transitive dependency cannot be in a table that has only one field as a non-key.
No, I mean in rent.
In the rent. Okay, the rent. Which one? Which one?
Maybe.
The property client.
Where is the transitive dependency here in this table? Where is it? Is it the rent? Is it
Rent
this?
finish.
Huh?
Rent finish.
Rent finish. Rent finish depends on what?
On
Silent.
on rent.
On
Silent
rent start. No, it's not depends on the rent start. When we say dependent on the rent start, that means you can find the rent finish based on the rent start. So if let's say the rent start is 1 to 20, rent finish is for example 31 12 21. If I ask you a question, if I said that, can you find when the rent is going to finish for the rent that starts on 1st of February 2020? Can you find this answer? Can you retrieve this data only? No, because in this case you are going to retrieve a very long list of dates, rent finish dates, for the contracts, for all contracts that start in the same date, right? You cannot determine this value based on only this value. But if I give you another question, if I say, can you find when the rent is going to finish for the property number 10 and the client number 50, then the information is going to be determined. So the result is going to be only one date. Am I right? Because if I give you the property number and the client number, you can find immediately what is the rent finish. And also you can find what is the rent start. And also you can find what is the rent itself. So that means they are directly connected or dependent on the full primary key. They are not dependent on another non-key fields. Okay? Is that clear? Is that clear or not?
Yes.
Yeah.
Okay, hopefully. Let us finish
Right.
this. Yeah, if you have any question, don't be shy, okay? Don't be shy. If you become shy, then you will never understand anything.
Right. Yeah. Transitive.
What is that?
Let's repeat it.
The transitive. Okay, the
Yeah.
transitive is if let's say this is the table, okay? I think you confused maybe. So maybe I need to properly explain this by example, okay? So suppose that we have all of this data here, like this, this, and this. Suppose that this one is client 1, client 2, client 3, client 4. This one is property 10, 20, 30, 40. Okay, suppose that this client number 1 with the property number 10, their rent start on 1 to 20. And this guy also starts on the same day. On the same day. This guy could start on different day, maybe 1 of May 20. This one could be 1 of July 20. Okay, is that clear? Then this one could the rent could be could finish on, for example, 1 to 30, for example. This one is 1 5. Let's say that suppose that the contract is 10 years. Okay, so here 1 5 20 or 30. This one is 1 7 is 1 7 30. This one is 1 second 30. And the rent here, suppose that this rent is 1000, this rent is 2000, this rent is 1000, and this rent is 3000. Okay, the question now, if I give you the rent start, for example, I am the client number 1. I'm the client number 1, but I don't know my number. I don't know my number. Okay, and also I don't know what's my property number. The thing that I could remember is only the starting of my rent. So my rent starts on this date, right? If you are the system, the person in charge of the system, if let's say I called you, I asked you, please, I want to know when my contract is going to finish. Then you will ask me, do you have your client number? I say no. Do you know your property number? I say no. So what do you know? I know only the rent start date. Okay, if I give the rent start, could the person in charge know when my contract is going to finish?
No.
Because based on this information, they will retrieve 2 values, right? Because this information is available here and here. Okay, if these 2 values are similar, then he can find, okay, it looks like all contracts that start on the 1st of February 20 is going to finish on the 1st February 30. But what if these 2 values, this one and this one, are not the same? what if these two values are not the same? Suppose that this one is 30 and this one is 38. Or maybe here also 1st of May 38. Then I give him this date. He will retrieve this value and this value. So in this case, this rent finish cannot be determined by the rent start. Cannot be determined. Right or not? And
Yeah.
you understand it now, right?
Yeah.
Okay. What if I give the rent start? Could I find what is my rent? Also cannot. If I say my rent start on 1st of February 20, then the system, the person in charge, key in the rent start value and try to filter, then he will retrieve this rent and this rent. He will not know which one is mine. So this field also cannot be determined by the rent start. Okay, so which one is, what fields that we can use to determine? So maybe you can say that if I know only the property name, then we can know the rent, right? In this case, based on this data, we can, right? If I say my property number is 10, then he immediately will retrieve only one value. Okay, what happens if this scenario is like that, which is very realistic? So if let's say this apartment number 10 was rented in the 1st of February 10 and the rent finishes on the 1st February, for example, 20. So before this contract finish, before we start this, okay, then the rent was only 800. Last 10 years ago, it was only 800. So in this case, if I said my property number is 10, then the guy is going to retrieve two rents, right? Also, two ends of contract. Also, two starts of contract. So partially, we cannot rely on the property number. That's why our design doesn't have any partial dependency, right? Also, suppose that this guy, this property was rented for person number 7, for example. Okay. So you may say that if I give the client number, the person in charge can find my information, right? So if in this case, if I said my client number is number 1, then they can know my property, which one is my property, rented property is number 10, because there's only one field has the value number 1. And also they can find my rent start, my finish start, my rent finish and the rent. But if let's say, and this scenario is also very possible to happen, very realistic. If let's say this client number 1 was renting another unit maybe 10 years ago, or maybe 1 year ago, or maybe at the same time he rents more than one property. So in this case, if let's say the property number is 50, for example, and I give my client number, I said my client number is number 1. So if the system person in charge keyed in my client number as number 1, then he is going to retrieve 2 records. So he is not going to know which one is the one, the contract that you are talking about, unless you give him the client number and the property number at the same time. So if let's say I give him, I said, could you check please when my contract is going to finish for client number 1 and unit number 50. So in this case, client number 1, this 2. Unit number 50 is only this one. So immediately they can retrieve my exact record. What if I say, please check for me the client number 1 and property number 10, only this one. So this one is unique, right? So all fields are based on the unique value. Is not based on partial or not based on other non-key fields. Okay? Is that clear?
Okay.
I think now is 1000% clear, right?
Yeah, doctor. Thank you.
Yeah, okay. Time is finished, and that's all about it. Alhamdulillah, we finish on time. And as you can see, the design is like this. The only thing that we have to do is only to have another table here, which is number and name, like that, for the owner. Owner here. This one is the primary key. This one is here foreign key. So this one's supposed to be like this, foreign key. Foreign key, we have to use dashed line for the foreign key. Okay, this one is not primary key. Okay, it's a foreign key.
But
Foreign key.
then
This one
where is the
is a primary key. Primary key. This one is a primary key. And this one is going to be connected here. So this is multi, this is one, and this is also going to be connected here. This is one and this is multi. Okay, and that's all. This is the entire design. Okay.
but after the
Yeah, if you
where is
don't have,
the transitive
yes.
where is the transitive dependency?
Now, is there any transitive dependency?
No, right? But recently you asked about the transitive dependency.
Oh,
There's no right.
I couldn't hear you, unfortunately. Can you talk close to the mic?
I don't have mic. Okay.
I cannot hear you like this, really. If you want, just write to me on the chat, I can read. Just write in the chat and I will read your question. It's also okay. I understand already. Okay, that's good. But please don't be shy. If you still have a question, don't be shy. Just send it to me even on the WhatsApp or maybe in the WhatsApp group or whatever. If you have any kind of question, just let me know. Okay? I hope you understand everything, inshallah. And if there is any question, you have many channels to contact me, the WhatsApp group, the private WhatsApp. Also during the classes of tomorrow and after tomorrow, you can ask whatever you want. Okay? For today, this is inshallah enough. Everything is went well. What we have only is the exercise of the exercise number 2. This one is an assignment also, okay? So before Monday, you have to submit this to the Butrablast. So I will create another assignment, number 2, then you submit to that, okay?
on Monday.
Before Monday. I don't want to pressure you, actually. I supposed to ask for this assignment tomorrow, but I don't want to put you under pressure.
Okay, thank you.
Okay? So before Monday, you submit to the system. Please make sure that your assignment is very well solved. Okay? It's very easy, very simple scenario, this one. Easier than the scenario that we have solved. Okay? Thank you guys for attending my class, and I hope everybody understood. If there is any question, you can immediately or directly contact me on WhatsApp, or tomorrow you can ask me during our classes. Inshallah, see you next class tomorrow. Assalamu alaikum.
Okay. Alaikum salam wa rahmah.
Terima kasih, Kak.